Hello, calculus. I'm a little freaked out here because I just realized the top of my cone is missing. Oh, I see it down there. Someone's playing tricks on me. All right, sorry. Back to your video. What two conditions? Did you figure it out between videos? All right, in order for us to use IVT, first, f of x must be continuous on the entire interval of a to b. Second, f of c must be between f of a and f of b. All right, so we are going to we have to make sure both of these guys exist before we can say we can use the applicability of the IVT. In other words, we can say, in order for IVT to hold, I'll hear a lot of calculus teachers say that, or IVT holds. This particular gentleman says IVT is either applicable or not applicable. Nice little vocab word for the SAT, right? All right, so f of x must be continuous on AB. This is where your pre-calculus comes in. A lot of students might say f of x is continuous on -1, 3. But they never remember, so yay, you got that. You remember that has to be true, but they didn't actually check to see if this is continuous. Where do we have a discontinuity for this f of x? One spot, right? Where is that one spot at? What is the one value for x I can't plug into that function? Hopefully you're saying -2. Why can't we put -2 in? Well, we have an asymptote there, Ms. Harris, because that would make my denominator 0. So for part 1, f of x is continuous on the interval -1, 3 because its only discontinuity is at x equals -2. Perfect. 2. Now we've got to prove that f of c is going to be between, so 2/3 has to be between f of -1 and f of 3, f of a and f of b, right? So we need to find f of 1, f of -1. That'd be -1 minus 3 over -1 plus 2. -1 minus 3 is -4. 2 minus 1 is 1. So f of -1 is -4. And we need to find f of 3. Plug in 3, I get 3 minus 3. 3 plus 2. 3 minus 3 is 0 over 5, which is 0. So you have to ask yourself, does 2/3 lie between -4 and 0? Yes or no? No, 2/3 is over here, right? It's bigger than 0. So we satisfied the first condition, but not the second condition, so IVT is not going to hold for this one. Here's the fancy way of saying that. Since f of c equals 2/3 is not between f of -1 and, probably should write out and, f of 3, then IVT does not, I want to say it the way I want to say it, is not applicable. I think if you said does not hold, you'd be fine. But is not applicable for f of x on -1, 3 if f of c is equal to 2/3. So in other words, we said, since 2/3 is not between -4 and 0, we can't use IVT because we didn't make that second point. All right, number 2. Where is my only discontinuity for number 2? We have another rational function. What do we have to worry about in rational functions? Asymptotes. Where do we find those asymptotes? It's what makes the denominator 0. So when x is -2, I have that point of discontinuity. Is -2 between -4 and 1? Yes. So are we continuous on this entire interval? No, we have an asymptote there. So we're going to say f of x is discontinuous at x equals -2. Therefore, f of x is not continuous on our interval we were looking at, right? Not continuous on -4, 1. Therefore, since we failed even the very first part of it, our first expectation, therefore IVT is not applicable for f of x on -4, 1 if f of c equals 2/3. Okay? Excellent. All right. I'm going to do one more. This one is great because it's got lots of stuff going on and it kind of freaks us out. What's our first thing we have to look for? Are we continuous on -2, 1? And when we look at this graph, I at least started freaking out. Do you know what the graph of e to the x plus 2 times cosine x looks like? No. So what we have to do is we've got to break that up into the two different functions and ask ourselves, is e to the x plus 2 a continuous function? Let's see what it looks like. Remember, it looks something like that, right? I can plug in anything for x. There's no discontinuities for this one. What about cosine x? What does it look like? Don't worry, I'm asking you to graph it, but you should know that the graph looks something like this, right? Did we have any poles or asymptotes? Was there anything I couldn't plug in for x? No. So for this one, I can plug in any x into these, and I'll have a defined function there. So p of x is continuous on any interval, really, but on the interval -2, 1, because p of x is never undefined. In other words, I can plug in anything I want to for x, and I will get some number out of there. Problem is, I'm going to make sure the number I get out of there, when I plug in c, is going to be a 5, and that's going to be between p of -2 and p of 1. So, we need to find p of -2 and p of 1. So we got e to the -2 plus 2 cosine 2. That'd be e to the 0 cosine 2, which is 1 times cosine 2, which is just cosine 2. Now, before you start freaking out, thinking, I don't know where to find that on my unit circle, don't worry. This is just one where you actually plug it into the calculator. And when we plug it into the calculator, it's -0.416. It's the first time we've come to this, so let's take a minute to talk about it. When we've got a decimal in calculus, you have to give exactly 3 decimal places. So 0.416. And then you're going to round to this guy here. You can't round it to 0.42. You can't make it 0.416753, whatever. It's got to be exactly 3 decimal places, and it has to be rounded correctly because they can tell whether you put it into your calculator right or wrong, depending on your answer. If it's off even by 1,000, so if you told me the answer was -0.417, you lose your point for it. Yes, it's that precise. Yes, I know they're picky, but it's good stuff for you. All right, p of 1 would be e to the 1 plus 2 cosine 1. That's e cubed times cosine of 1. And that is going to be 10.852. How did we get that? Plugged it into a calculator. All right, so we need to ask ourselves, P of C is 5. Is 5 between -0.416 and 10.8? You betcha. So P of C equals 5 is between P of -2 and P of 1. So we've shown that it's continuous because it's never undefined. We've shown that our P of C value, which is 5, is between P of -2 and P of 1. So therefore, IVT is applicable on -2, 1 if P of C is equal to 5. All right, and then it says, if it's applicable, find the value of C guaranteed to exist by this theorem. So P of C is equal to 5. So e to the C plus 2 times cosine C has to be equal to 5. And he just magically writes this down. I think the only way you can find this is just to plug it into your calculator and find the value there where y is equal to 5. So we'll practice maybe doing that a little bit tomorrow. Don't go away just yet. Actually, let me go ahead and scroll it down so you can pause it on this video. I want you to take a look at these two problems, see if you can determine whether IVT is applicable or not, and we'll talk about them in the next video.